Multicast DNS or mDNS is a very popular protocol that supports zero configuration service. Apple's AirPlay and AirPrint are example services which are related to mDNS. If you only have simple network configuration, for example, just one network, one VLAN, mDNS is really zero configuration. You even don't know its existence. You don't need to change anything. It just works right away. It's very reliable. But once you introduce VLANs, you may have different issues here and there, and sometimes you even don't know whether it's doable in your multi-VLAN scenarios. So in this video, let's discuss several typical scenarios. Let's see how we can support them. First scenario is the simplest one. Even though you have multiple VLANs, you do not want the mDNS services cross VLAN, which means you want the services work within their respective VLAN. The second scenario, you do want all your mDNS services cross VLANs. Third scenario, you only have selective VLANs. For example, the VLAN 30. For some reason, you do not want the mDNS services within this VLAN to be discovered by other VLANs. The last scenario, you have much more flexible requirement. So for some services, you do want them to be discovered in other VLANs. For some, you do not. Okay, let's get started. Avahi Reflector plays a very crucial role when it comes to mDNS across multiple VLANs. If we enable the reflector in Avahi, the Avahi daemon will reflect incoming mDNS requests to all the enabled network interfaces, allowing clients to browse mDNS services on all the enabled VLANs. Let's talk about how Reflector works. When you disable Reflector, which is the default setting in Avahi, for example, if you have two VLANs, default VLAN and VLAN 20, in VLAN 20 you have a Apple TV, in VLAN 1 you have a printer. From VLAN 20 you have a computer, you send out a mDNS query. By the way, here we need to explain what is QU, what is QM. So in mDNS there are two types of queries. QU means unicast query. QM means multicast query. Don't be confused. The query itself is always sent to this special multicast address, but QU means the client expects the answer, the response, to be sent out in a unicast way. QM means the response has to be multicast, meaning the response also need to be sent to this special multicast address. So in this scenario, the VLAN 20 computer send out a QU query to this IP address. Of course, all the devices within the same VLAN will get that. For example, this Apple TV will receive the query, and then because the query is unicast query, so the Apple TV will directly respond back to the machine. The packet will send back to the machine telling this Mac computer that, okay, there's a Apple TV in the same VLAN, right? These two packets happen in the same VLAN, VLAN 20. In the VLAN 1 side, because we disabled the reflector, multicast query won't reach another VLAN, so this printer will not receive the query at all. Of course, it won't respond, and then this Apple machine will not be aware of the existence of this printer in another VLAN. This is when the reflector is disabled. If we have the exact same devices, exact same VLAN configurations, but only in Avahi side, we enable the reflector. Let's see what will be different. The Apple TV part, it will still respond back. There won't be change in the same VLAN, VLAN 20, but the change is in the VLAN 1 part. Mac computer first send out the same QU mDNS query. Expect to receive unicast answer sent to this special multicast IP address. Because we have the reflector enabled, Avahi daemon received this query, and then the avahi service will send out the exact same query, but in VLAN 1 instead of VLAN 20. So that's the so-called repeater or reflector. Avahi will also change the query to QM instead of QU because the Mac computer doesn't exist in VLAN 1. If some devices respond back to the Mac machine, it doesn't make sense, right? That's why the mDNS query need to be changed to QM and it's in VLAN 1. Because the query is in VLAN 1, of course, the computer will receive that, the computer will respond back, and because the query is in VLAN 1, of course, the response is also in VLAN 1. And then avahi will detect this response. Then avahi will repeat the response, but this time in VLAN 20. Then because the Mac machine is running in VLAN 20, it can detect this VLAN 20 response. So in this way, avahi helps the two devices to communicate indirectly. So basically the avahi is relaying the traffics, is repeating the traffics, is reflecting the queries. Okay? The first scenario, you do not want your mDNS service to cross VLANs. It seems to be very simple. Someone may think, okay, if you do not do anything, then you automatically achieve this effect, right? No, not really. So let me show you. If you use Ubiquiti devices, in the right side, I'm showing you the network controller. Let me create a new VLAN. Under the menu, you can see the multicast DNS is enabled by default. If you didn't change it when you create the VLAN, it's very possible other VLANs will discover the mDNS services within your new VLAN. To disable it, you need to go to the network setting and deselect the mDNS. Internally, if you enable it, your UniFi router will run a avahi service on the interface for this particular new VLAN. If you do not use UniFi devices, you can also support the mDNS across multiple VLANs. For example, you can run a avahi service. So in the lower left, I'm showing you a default avahi configuration. I didn't change it. It comes with the default Linux installation. In the configuration file, under the reflector section, you can see this commented out setting. Enable reflector equals to no. So by default, if you don't change it, the reflector is disabled. Reflector means avahi service will not act as a mDNS repeater or reflector, so that your mDNS services will not support multiple VLANs. Depending on your hardware and software configurations, you do need to pay attention to the settings to achieve the effect for the first scenario. In my lab environment, I have 4 Mac machines connected to 4 different VLANs. Each VLAN has some unique mDNS services, and then let's see, after we disable the reflector setting, how the scenario 1 works. Let me demo what will happen behind the screen. By the way, from UniFi network controller, you can see I disabled the mDNS. UniFi router won't run avahi service, and then I'm running a separate avahi service in a Linux machine. Let me show you the configuration file. As you can see, the enable reflector is currently disabled. The avahi service will still be running, but it will not enable the reflector service. Then from the right side, VLAN 20 Mac machine, let me start Wireshark, and I already filtered on mDNS. mDNS entries will be cached in every machine. Just to show you the effect, let me force a update, kill the mDNS responder service, restart it. Okay. Right away, you see something happened, right? Then let me stop capturing. Let's look into the captured frames. Let's use the diagram as a reference. First, the Mac Mini need to send out a QU mDNS query, right? See the captured first frame. This Apple machine sent to this special multicast IP address. It is a QU as indicated here. If you check the frame details in the mDNS query part, you can see a long list of questions. The Apple machine wants to know everything. about the existing mDNS service in the same VLAN. Then see the second frame is from this Apple TV. The Apple TV directly replied to this Apple machine. Why? As explained earlier, the Apple TV also can detect the queries sent to this multicast address, and because the query is QU, so the Apple TV directly responded. That's why you see the second frame. Because it's zero configuration protocol, each device is equal, there's no central server, so the Apple TV also want to advertise its own service. That's why you see the following frames as well. Then let's move on to the second scenario. This time we want to enable the reflector so that mDNS can cross VLANs. If you use Ubiquiti, the easiest way is to simply enable the mDNS setting in the network configuration, right? But let me show you the more generic way using a standalone avahi service. So in this Linux, let me uncomment this line. So you see the enable reflector is yes. Save it. Restart the avahi daemon. From the Wireshark, let me capture the frame. Just like in previous scenario, let me restart the mDNS responder so that we can see the refreshed mDNS query and responses. Done. Go back to Wireshark, stop capturing. Before we look into the captured frames, let's check the Linux I'm running avahi with. So in the network interface configuration, I configured it in the way that I have 4 interfaces in total. Each interface is for a VLAN. I have 4 VLANs. So in the Linux, I have 4 interfaces. I only have one physical RJ45, but I can configure 4 different interfaces. Then let's check the avahi daemon's configuration. So in the beginning, see the allow interface and the deny interface. Because they are both commented out by default, all the interfaces are automatically allowed. This is just about why the avahi server can respond to 4 different VLANs by default automatically. Okay, now let's go back to the captured Wireshark frames. So let's check the frame starting from this one. Let's also use the diagram as a reference. The Mac Mini need to send out a QU query to the same multicast IP address. Keep in mind, no matter whether you have avahi or not, whether you enable the avahi reflector or not, the client machine, for example, this Mac Mini, it doesn't know anything about it. And it doesn't need to know anything about it. Just in the normal way, it will send out the QU to the same IP address. And then starting from the next frame is totally different than previous scenario. See, the IP address is from VLAN 30. It is a query and it is a QM. That's what I show here in the step 2. Because the avahi service received the query which the Mac Mini sent to this IP address on VLAN 20. And then the avahi service reflected the queries in all the interfaces. You can see 30, 1, and 10. Why not 20? Because the 20 is where the client machine is from. So avahi doesn't need to help. So that's why you see the 3 queries, but they are changed to QM instead of QU. That's what avahi reflector does. Because in each single VLAN, there is such query. All the machines from each VLAN will respond back with their knowledge about the mDNS service. For example, from the VLAN 10 machine, and from the VLAN 1 machine, and from the VLAN 20 from the Apple TV, it also responded. So every single machine will respond back because they received the QM query in their respective VLAN. And then the avahi server, see the IP addresses ending with 99 in different VLANs, they will send to this multicast IP address with responses. Then in each single VLAN, all the devices will receive the answers from other VLANs. In this way, the reflector helps the mDNS query to cross VLANs. Let's move on to the scenario 3. So you have a very secured VLAN, VLAN 30. For example, it has some SSH services. You do not want other VLANs to discover this service. How you can do that? If you use UniFi devices, it's very easy. For example, here in multicast DNS, you simply enable it and then select other VLANs, just excluding VLAN 30. Then you are good. But in this video, let me show you the more general way if you have your own Avahi server. Let me edit the Avahi daemon configuration file. So there are these two lines which are commented out. One is allow interfaces, the other one is deny interfaces. You have two ways to achieve the effect for this scenario. You either for allow interfaces, you list out all the interfaces you want to enable the Avahi service, or you simply list the ones you want to exclude under the deny interfaces. So let me do it in the second way. Because we are talking about VLAN 30, so this is the interface I want to exclude. Save it. Before we restart the Avahi daemon, now the old configuration is still effective, which means in VLAN 30, I should be able to see other VLAN services, and from other VLANs, I should be able to see this SSH, right? So let's validate it. I'm going to use a free external tool for macOS. It's called Discovery. You can achieve the same thing in command line by using DNS Service Discovery tool, but the GUI is much easier for most people. I have launched the Discovery tool in all 4 Mac minis. For example, from VLAN 30, I can see the Apple TV. From VLAN 20, I can see the printer from VLAN 1, file share from VLAN 10, right? Similar situation, let's say from VLAN default, I can see its own printer service. I can see VLAN 30's SSH service. So the exact same situation, because at this moment, we enabled the Avahi service in all the VLANs, and we enabled the Reflector services in all VLANs. Now let me restart the Avahi service. After we made the change to the configuration, we just excluded the VLAN 30 interface, right? So let's restart the service now. Okay, just give it some time. So let's check the VLAN 30 first. I can still see the SSH service by itself because it's in VLAN 30. It makes sense. But strangely, I can still see services provided by other VLANs. For example, the AirPlay, for example, the printer service. So let's make sure we have the new information. Let me kill the mDNS responder in VLAN 30. After the refreshing of the services, the current situation makes sense. As you can see, it can still see the SSH service provided by itself, but all the services originated from other VLANs, they are gone. For example, the AirPlay, for example, the printer service. And then from other VLANs, for example, from VLAN 10, I don't see the SSH service from VLAN 30. From other VLANs, the same situation. So we have successfully achieved the effect. This is the end result of the scenario 3. So from the non-30 VLANs, for example, from VLAN 1, we can see its own service, but we cannot see the VLAN 30 service. And from other VLANs, for example, VLAN 20, we can see its own Apple TV, but we cannot see the VLAN 30's SSH. So we are good about scenario 3. This is an easy one because you can easily do it either in standalone Avahi or using the network controller provided by Ubiquiti. Move on to the last scenario for this video. So we still have 4 VLANs, but we only want the printer service, the AirPrint, to be discovered by other VLANs. For all the other services, we only want them to be discovered within their own VLAN. To achieve this type of selective service requirement, we cannot use UniFi devices provided function anymore because it doesn't allow us to cherry pick the services. So we can only do it using a standalone Avahi server. In this scenario, for example, from VLAN 1, of course, it should be able to see its own AirPrint, but not other VLAN's service. And from VLAN 10, yes, it can still see its own shared file service, and we require it to be able to discover the AirPrint from VLAN 1, but it shouldn't see the AirPlay from VLAN 20. Then from VLAN 20, a similar thing, it should be able to still see its own AirPlay, but it cannot see VLAN 10's file share. It should be able to see VLAN 1's AirPrint. So let's see how we can achieve that using Avahi. In the Avahi daemons configuration file, if we move to the end, we can see the reflector section. In previous scenarios, we enabled the reflector, right? But you can see there is another line here. It's called reflect filters. Here, you list out the mDNS services you want Avahi to help you to reflect in other VLANs. By default, it's commented out, which means there's no filter. The reflector will reflect all the services. In this scenario, we only want the reflector to help on AirPrint. So we want to list out the AirPrint service name and how we can find out the exact service name. For example, in the right side, in the VLAN 1's tool, you can see for printer, it's under this section called IPP. It's for AirPrint. And similarly, we have a IPPS. It's for secured, the encrypted AirPrint service. So for example, we want to enable the IPP service, right? So we simply put the service name here. That's it. That's how simple it is. If you need other services, you simply add comma and list them out. Okay, so let me save the changed file. Okay, saved. Before we restart the service, let's validate. At this moment, other VLANs, they can still see non-AirPrint service. For example, from VLAN 1, I can still see the Apple TV service here. We can validate it from the screen mirroring. Yes, I see the Apple TV is listed here, right? For example, from VLAN 20, let me go to Finder and then Network. I can see the VLAN 10 machine, the MacBook Pro. If I click on it, see here, I can connect, which means it has the file share service. So at this moment, in VLAN 20, we are able to discover the file share from VLAN 10, right? We validated two examples before we enable the Avahi daemon configuration change. So now we are ready to make the change effective. Let me restart the Avahi daemon. And we need to give all the computers some time to refresh the mDNS cache, or we can force the refresh. For example, let me do it in VLAN 20 machine. Kill the mDNS responder. So from VLAN 20, we can still see Apple TV. That makes sense. But if I go to Finder, Network, I don't see the MacBook listed out anymore because it doesn't discover the file share service, right? So this is an example from VLAN 20. Then from VLAN 1, you can see the AirPlay is gone in the discovery tool, but let's validate it, whether it's really gone. From screen mirroring, see, it doesn't list out the Apple TV here. But let's see whether the printer service is still able to be discovered in other VLANs. That's our major functionality we want to achieve in this scenario, right? So let me test it, for example, in VLAN 10. In fact, we can already see the service is still there, right? But just to make sure it's really the case, let me go to printer setting. Let me try to add a printer. See, Bonjour shared. It lists out the printer shared in VLAN 1. Okay, this is the VLAN 10 situation. So in other VLANs, it's the same situation. For example, in VLAN 20, in VLAN 30, let's try it. Try the same thing. Let me add a printer. It doesn't discover anything. Why in VLAN 30, we cannot find the AirPrint service? Because remember, in previous scenario, we completely disabled VLAN 30, right? So that means even though we enabled the AirPrint in the reflector filter, it won't be effective in VLAN 30 because it's completely disabled. Okay, I hope we are clear about the different combination of requirements regarding mDNS services across VLAN. This is the end of the video. Thanks for watching.